What's going on, General Math? We are moving on to 10.2 with the fundamental counting principle. So, little introduction to what a factorial is. Right here, a factorial is used to represent the product of a number n multiplied by all the numbers smaller than itself, all the way down to 1. And it's represented by an exclamation point following that number. So whatever number this n is, say it's 6, if we follow that 6 by an exclamation point, we're going to take 6 times 5 times 4 times 3 times 2 times 1. So as we can see in our first example, 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, which is 720. Interestingly enough, the factorial of 0, right here, 0 exclamation point, is just 1. It's kind of like if we took like something to the 0th power, right? Like 4 to the 0 power is still 1. And then if we have a factorial divided by a factorial, I like to expand out the top and bottom before we start multiplying and canceling things. So 5 factorial would be 5 times 4 times 3 times 2 times 1. 3 factorial would be 3 times 2 times 1. And then we're going to cancel out. So if we have something on the top of a fraction and the bottom of the fraction, they can cancel. So I have a 1 on top and a 1 on bottom. Those cancel. Same with the 2's. Same with the 3's. And what's left over? Just 5 times 4. So 5 times 4 equals 20. Another example, we have the factorial of 9 over 5 factorial times 2 factorial. So I'm going to list out the 9 factorial right here, list out the 5 factorial, and then list out the 2 factorial. We can cancel off the 5, 4, 3, 2, and 1, 5, 4, 3, 2, and 1. So all we have left over is the 9, 8, 7, 6, and the 2 times 1 from right here from this 2 factorial. And then let's solve the top. Let's multiply all these together. Multiply these together, and then we're going to find our answer of 1,512. 7 minus 3 factorial, let's just work inside the parentheses first. 7 minus 3 is 4. 4 factorial is 24. And then same idea here. If we have some values for a variable, we can just plug in 6 for A and 2 for B. So A factorial turns into 6 factorial. A minus B factorial is 6 minus 2 factorial, which is 4. 4 factorial. I'm going to list these out, 6 all the way down to 1, 4 times all the way down to 1. We can cancel off 1, 2, 3, and 4, 1, 2, 3, and 4. What's left over? 6 times 5, which is 30. So arrangements. In our first example, we have the 5 trucks in the parking lot include a blue, red, black, white, and silver truck. How many different orders could we park those trucks on any given morning? So we are just going to take the 5 different options of trucks, right? Because we have 5 different options of trucks right here, and then find the factorial of it. So 5 times 4 times 3 times 2 times 1. And there's 120 different ways that we could park those 5 trucks out in the school parking lot. Second example, we have a drawer of black and white socks. So there's 2 different options, either a black sock and a white sock. My room is dark. This is a classic problem. My room is dark when I get up early, so I can't see what sock I'm pulling out. Believe it or not, some days that's how I feel as well. If I pull out 6 socks, how many different combinations of socks could I have? Well, I had 2 different options I could pull out. I could pull out a black option or a white option, a black sock or a white sock. Right? So we're going to take 2 to the 6th power because I'm pulling out 6 socks. So that's 2 times 2 times 2 times 2 times 2 times 2. So there's 64 different combinations of black and white socks that I could pull out on any given day. Last example here, we have the word attract. So attract is made up of A, T, T, R, A, C, T. Notice there is 2 A's and there's 3 T's in the word. We're going to find distinguishable arrangements. So there's 7 total letters, but again, there's 3 T's and 2 A's. So we do have some repeats. If we want to find the distinguishable arrangements for this word attract, it's going to be the total amount of letters with the factorial taken. So we had 7 total letters, right? There's 7 letters here, so 7 factorial over the factorials of any repeating letters. So we had multiple t's. How many t's did we have? 3. So let's take the factorial of it. And how many a's did we have? We had 2. So we have 7 times 6 times 5 times 4 times 3 times 2 times 1. And then we had 3 factorial and 2 factorial. Well, let's cross off the 3 times 2 times 1, 3 times 2 times 1. All we're going to have left over is 7 times 6 times 5 times 4. Figure out what that is. Divide it by 2 because 2 times 1 is 2. And we get the answer of 420. You don't have to cross these off. You could plug all of these into your calculator. I just think it saves you some time punching buttons. That's all for today. Let me know if you need help on the homework.